Okay, so you're welcome to our very first lesson on organic chemistry. And like you see on the screen, this is Introduction to Organic Chemistry. So let's get started. So what do you have today?
Okay, so today we are going to look at the introduction to organic chemistry. Then we'll talk about how organic chemistry came to be and what organic chemistry is.
So I'm sure there are a lot in store for them. So do you think they will enjoy this lesson?
Of course, very much, because there are some students who already have some notion about organic chemistry as being difficult to understand. But this lesson is going to make it very simple.
You are sure of that?
Very sure of that.
Okay. So I think the best place to start is the history.
Yeah.
The history. And according to the history, around which century did organic chemistry begin?
So it was way back in the 18th and the early 19th century, where people believed that organic compounds, that's those fancy molecules found in living things, could only be made by living creatures.
And interestingly, that's what scientists actually believed. They believed that if you are not a living thing, you are not making organic compounds. Interesting. So organic compounds could not be made in the lab. And interestingly, they held on this belief to the extent that they even had a mystical concept for it. And they call that mystical concept the vital force theory. Vital force theory. But what does that theory say?
So according to this theory, the scientists were saying that you could not make something like sugar or urea in the lab unless you are having a living thing. That could be a goat or a tree.
Can you imagine? So if you don't have any living thing standby, there's no way you can make an organic compound. That has been the belief they held on to for so many years, all the way down to 1828. 1828, until when a young chemist who happens to be a German at the same time, his name Friedrich Wöhler, he prepared what? What did he even prepare?
He prepared urea.
Good. And what makes it quite interesting was he prepared this using inorganic salts. So he prepared an organic compound using what? An inorganic substance. And he did this by heating ammonium cyanide. You see how interesting it is?
Yeah.
And the fact about this whole thing is he did it without using any what?
Any plant, no plants, no animals.
Just a salt, his test tube in a hot plate. So he disproved that fact. So this single experiment by Friedrich Wöhler actually completely destroyed the vital force theory. It completely destroyed, like a wrecking ball through a wall of outdated ideas. So in this case, the wrecking ball was Wöhler's experiments, and the wall of outdated ideas was the vital force theory. This single experiment was so powerful and it sparked the birth of organic chemistry as a proper science. So what that means is that way until before the time of Friedrich Wöhler, organic chemistry wasn't considered a proper science. Just imagine the belief they had, the vital force theory. And since that day, the world has never been the same. No. The world has changed since that single experiment. And according to the notes, something happened after chemists realized that. What happened?
So from then, chemists have been cooking up everything, from painkillers to plastics, and they make them from carbon atoms in their scrap.
So now scientists got to know that, well, organic compounds do not necessarily have to come from living things. They can produce them in the lab. That knowledge alone gave them the power that they could make medicines in the lab. And I think it's a very, very nice stage in the history of mankind. So, what is organic chemistry? Friedrich Wöhler has been so good to us. He was so successful in firing the vital force theory, he sacked it completely from its post. So now that we have been successful in firing the vital force theory, I think we have to do our best to define what organic chemistry is. So what is organic chemistry?
Organic chemistry is a branch of chemistry that deals with the study of the structure, properties, reactions, and preparation of carbon-containing compounds, especially those with hydrogen, oxygen, nitrogen, sulfur, and halogens.
Good. So this looks like a really long definition. What do you think?
Yeah.
It looks long, but the fact is just a simple definition. Or this entire thing can just be simplified as organic chemistry is the branch of chemistry that deals with the study of carbon-containing compounds. But that's really simplified. So when we are saying we study carbon-containing compounds, what we really mean is we are studying the structure and properties of these compounds, the reactions they undergo, and how to prepare these compounds. That's basically what we mean by studying organic chemistry. But if you take a very close look at the definition, we said studying carbon-containing compounds is organic chemistry. So why are we focusing on what? Carbon. Why? To put it simple, carbon is the social butterfly of the periodic table. It's because carbon is so unique. But what makes carbon unique? It has been stated out there. It can form how many bonds?
So carbon can form 4 bonds.
4 bonds.
It can also create chains, rings, branches. And sometimes it even creates double or even triple bond.
Interesting. And the good news is no other element or atom can do this. Only carbon can. This is quite unique. So imagine a group of elements, atoms. They must be very, very jealous of carbon because carbon is so versatile. So 4 bonds, and you can see that it can have chains, rings, double bond, triple bond. Oxygen can't, nitrogen can't do all of this. So carbon is behaving as though it's that guy in the room who has gotten something to prove to his colleagues. That is why carbon is so unique and has gotten an entire field on its own, organic chemistry. So why is organic chemistry so important? I think that's our next point to talk about, right? So now we have to imagine life without organic chemistry. Let's imagine life without organic chemistry. That would be a total nightmare. And why is that the case? Because without organic chemistry or organic compounds, there will be no food. What's your favorite food?
Probably rice.
Probably. Do you like fish and meat?
Of course.
What about chicken?
Very much.
So all of these things contain organic compounds. So that means without organic chemistry, this favorite food that I just mentioned, you wouldn't have them. Can you imagine life without food?
No.
So without organic chemistry, you don't have what?
No food.
You don't have food. The next will be there will be no medicine. So without organic compounds, we wouldn't have paracetamol and other painkillers. Can you imagine having severe pain? You need painkillers, but there are no painkillers around. So you see how important organic chemistry or organic compounds are to humans.
Yeah.
What else? There will be no what?
No clothes.
No clothes. Because the cotton, the polyesters, the nylons, all of these are what? Organic. Oh, the clothes you are wearing, is it cotton or polyester?
Cotton.
It's cotton. 100%?
100%.
100% cotton. You sure of that? 100% cotton. So that's organic, right?
Yeah.
So without organic chemistry, you wouldn't have what you are wearing on you. Unless otherwise you are a kind of person who is interested in prehistoric fashion. Stone Age. But even those guys also, we can say with certainty that even with all, they also depend so much on organic compounds. And also without organic chemistry or organic compounds, we wouldn't have plastics, no fuels, no phones, no soaps, no perfumes. And then no chocolates.
Ouch.
No chocolates.
Yeah, just imagine life without chocolates.
But do you enjoy eating chocolates?
Very much.
You sure of that?
Very much.
So imagine life without chocolate. I think life without chocolate would be so good. Especially for the guys.
No, that's something that you just want to cause confusion right here.
Why?
Life without chocolate. Can you imagine not being able to have that your favorite chocolate?
I think life without chocolate is good. My personal opinion. Because now so many ladies disturb guys about chocolate.
That's too bad for you.
Too bad for us. I think ladies have organic chemistry to thank, or organic compounds to thank.
Yeah, we are grateful.
They are grateful. So without organic compounds, you do not have these things. So that's how important organic chemistry is, organic compound. And it doesn't end there. Even our DNA and blood also contain organic compounds. Really? So everything we can think about contains organic compounds. So we can say with certainty that organic chemistry runs the world. There are some fields out there that also rely on organic chemistry. What are those fields?
So biochemistry, pharmacology, agriculture, and even cosmetics.
Wow. Cosmetics. When I hear cosmetics, I think about you guys, you ladies out there.
Yeah. Life without our makeup, our cosmetics for real.
That would be a nice life,
That would be awful.
You're perfect. Yeah. How would I put it? Paint your faces with all those things.
We love to paint. That's also art.
What? Makeup is art.
Yeah. Painting
Your face is art.
Yeah.
Okay. I think this is the first time I've heard this anyway. Well, so that is organic chemistry, how important it is. So organic chemistry actually runs the world. But now let's look at some sources of organic compound. When it comes to the sources of organic compounds, we can split them into two. We have the natural sources and the synthesized organic compounds. So we look at the very first one, the natural sources. Those are the ones that we can say are born that way. So the first one will be plants. From plants, you can get sugars, oil, and some vitamins out there. What are the natural sources do you also know?
We can also get some from animals. What we get from them is the proteins, the fats, the enzymes, and hormones.
Oh, nice. So all of these are organic in nature.
Yeah.
Proteins. Wow. So they are carbon-containing compounds. No wonder you say carbon-containing compounds are so versatile. We also have microorganisms. Without them, we don't have antibiotics. Penicillin and alcohol. Alcohol.
Yeah.
Okay, for those of us who are not fan of alcohol, we have no issues with that. But can you imagine those who love alcohol, but you don't even understand anything about organic compounds? Oh, that's quite interesting. They love alcohol, but they have no knowledge about organic chemistry or organic compound. Okay, that was just by the way. What other source do we have? We have fossil fuels, crude oil, natural gas, and coal. So these are some natural sources of organic compounds. What about the artificial, the synthetic sources? Those are the ones made in the lab. We have what? Medicine. What are some examples of medicines that contain organic compounds?
So we can have aspirin, paracetamol, and the anti-malarial drugs.
Oh, okay. So all of these are organic, they contain organic compounds. Wow. So is it safe to say that organic chemistry runs the world? What do you think?
Yeah.
Every aspect of life. From our clothing to your cosmetics, all the way to the medicines. Quite interesting. We also have plastics, polythenes, PVC, and then other stuffs like but what's the full meaning of PVC? PVC, polyvinyl chloride. Okay, look for the full meaning of PVC. If you know it, to put it under the comment section. Well, some other synthesized sources. We have fabrics, then dyes and paints. And then we have cosmetics. That is the next one. Cosmetic appears here again. You have lipsticks, lotion, shampoos. All of these are chemistries. Can you imagine ladies saying they don't like chemistry, but they use lipsticks a lot? I think all ladies that do not like chemistry should be stopped from using lipsticks. What do you think?
Yeah, you're right.
You really
At
agree
least we
with that?
have to know what the lipstick is made up of before we use them. And we have these lipsticks are all made up of organic compounds.
So what's your favorite brand of lipstick? Or you don't have any favorite brand?
I wouldn't like to blurt that out.
Really? Okay, what are some of the organic compounds from your favorite listing? Oh, never mind. Okay, so I think we should promote that any lady that doesn't like organic chemistry shouldn't be allowed to use lipsticks. Yes, even their shampoos and lotion, they should be stopped, because all of these are substances that contain organic compounds. So closing thoughts. You see, carbon, well, might be a tiny atom. Yes, maybe carbon may be a tiny atom, but in the world of chemistry, it is the main character, the drama queen, and then the what? The hero. All of this rolled into one. So carbon is so important in the field of what? Chemistry. So the next time you eat a cookie, wear a shirt, or take a pill, or even breathe that fresh air you love so much, you must thank who? You must thank organic chemistry. So this brings us to the end of our introduction to organic chemistry. If you find this lesson quite interesting, what do you think they should do?
You have to share it with your other friends.
Okay.
Then you have to you have to subscribe so that every time we post a new video, you'll be updated.
I think you heard it all. Subscribe to the channel. But what do we have next? Next lesson, what should they expect?
In the next lesson, we are going to classify organic compounds. So there we are going to know of hydrocarbons and hydrocarbon derivatives. We'll get to know of aliphatic and aromatic compounds. We'll get to know of saturated and unsaturated organic compounds, open chain and cyclic compounds.
Good. So there you have it, right? So don't miss these lessons. And just like this one has been so interesting and I think entertaining, maybe. We hope the next one will be like that. And if you have any suggestion or any question at all concerning the lesson, you can leave it in the comment section. This is the very first lesson in this series of organic chemistry. So subscribe so that you do not miss any future lesson. See you next time.